Hello everyone, my name is Andrew and today we're going to continue talking about IT and architecture. In this video, we're going to talk about a very interesting topic, which is problems of microservices. So what is microservice architecture? Basically, you have your application. So that is not microservices, that is called monolith. So what you have is your user, your application, and typically a database. We assume that every application has a database to save the data, to do some stuff with it. So what we have in a typical app is your app and the database. That's it. It can be a console app, it can be a web app, it can be anything. So your programming language is here. Let's assume that it's Python. And your actors, so your users, talk to your app directly, and then that app connects to the database. That is the main idea of the normal monolith application. But now let's take a look at microservices. So sometimes our application are so big, so enormous, or we can't really manage the code in one app. So what we do is we split different features of our app into different applications. So instead of one app, you're going to have different apps that work together, and it seems as it is one app from the user's point of view. So what we have here is our actor, which talks to 3 apps simultaneously. So you can have your front end, so your HTML page here, and 3 different websites or 3 different projects that work with each other, and it seems like it's a complete app. So let me give you an example of Google. Google as a company has lots of apps. It has YouTube, it has Google Analytics, Google Pay, Google Wallet, YouTube Analytics, then Google Account, and all those apps work together as one big entity. And for example, you can use your Google account in Google Analytics and YouTube simultaneously. And that's how it works. That is microservices. But today we're going to talk about the problems that are associated with microservices. And why is that? Because a lot of people and a lot of companies choose microservices because they're fashionable, new, they're cool, and it's always kind of like more cool to say that you work with microservices because that architecture is far more complicated. So your project is bigger, everything is better, and you're a good programmer. But it's not always the case. The thing is, when you use microservices, you make a lot of mistakes. You make a lot of problems, and some of the problems that you make, some of the problems that microservices introduce into your project cannot be fixed very easily. And once again, today we're going to talk about microservices. So I worked with them for, I don't know, maybe like 3 or 4 years already. And the first problem that a lot of people make, a lot of companies make when they use microservices instead of monolith apps is that they don't need microservices at all. The thing is, you only need those when your project is big, when you have a lot of traffic, so you can't really work with one big project, or when you cannot manage your code. And most of the times you can omit those problems with some other things. So if you want to manage your code better. If your project is big enough, try the load balancing with 2 different projects. So try something. But microservices is not for everyone. If you're a small project, if you're a startup, if you can work with your current code, so you don't need a lot of projects to manage it, then you don't really need microservices. So you only need those whenever, first of all, you have a lot of traffic, so you can't really manage all the components of your system. Then your code is very, very big, so your repository on GitHub or on GitLab is enormous, so you can't really manage your code. And when your team is so big, so let's say you have 20 people in your team, that is when you need microservices. Of course, it's not always the case, but one thing that you should always remember is that not every project and most projects don't need microservices at all. So that is the first problem that we have. The second problem comes with people. Whenever you develop microservices, your programmers should be educated enough, because microservices as an architecture has a lot of patterns. One pattern is right here. So for each microservice, you should have your own database. If your programmers, if your team does not know that this pattern is, if they don't know this pattern, then you can introduce a lot of mistakes and a lot of problems into your project. If your team doesn't know how to manage dependencies or how to even split different features of your application into different services, so let's say that instead of 3 services, we chose to do users and products. Maybe that's a mistake. Maybe that is not a mistake. So it always depends. You always need to know a lot of patterns like CQRS, then SAGA, so SAGA pattern, in order to work with your microservice architecture successfully. Because microservices, once again, introduce a lot of patterns. And if you don't have a well-defined team that knows how to deal with microservices, then they will spend a lot of time and a lot of money just working on the mistakes that could have been avoided. That's what I'm trying to say. So what you need to do is have a good team. And that is our second problem. The third problem is technical. So the first 2 are like conceptual, but the third one is about data synchronization. What is the problem? The problem is that we have different databases, and if you work with monoliths, you only have one of those. So only one database and your project works. But here we have 3 different databases. And why is that an issue? Because you don't have ACID transactions and you need to somehow synchronize your data. So let's say that we make an order. That is an online shop. So Amazon, by the way, uses microservices, but of course it's a big company. But let's say that we do an online shop and our actor, so our frontend, our user sends a request to orders. Orders has to somehow talk to users. So talk to users to get some data about, let's say, user balance. So does the user have enough balance to pay for that order? What happens if we change something in database number 1, but then orders just shuts down? So service orders just shut down. What do we do with the changes in the database number 1? So you always need to think about data synchronization because you have different databases, and if you have one database, then you have problem with data dependencies, which is far more problematic in most cases. So what you need to think about is data synchronization. Of course, there are patterns for it, like event-driven services, and I have a separate video on events in microservices and why it's almost always better to use events than HTTP when it comes to data synchronization and just dependencies in microservices. And you can use eventual consistency with event-driven services, but of course it's very, very hard. It's easy to say, but it's hard to develop. And that is our third problem, data synchronization. The fourth one is kind of obvious. So you have 3 different databases, you have 3 different projects, and you have 3 different teams, because one other pattern, which is like conceptual, that for every microservice, for every service, you should have a separate team. If you follow all those patterns, if you have 3 services, then you need at least 6 servers. So you need to have at least 6 servers on Amazon AWS, on Azure, Google Cloud, or whatever you want to use. And why do you need 6 services? Because each service should have its own server. Because if all your services are on one server, then most of the microservice advantages are depleted. So you don't have them. So you should have a lot of servers, and a lot of servers means a lot of money. Aside from that, you need a team which is competent enough, and competent people usually take a lot of money for their work. So microservices are really, really, really expensive, and we're only talking about 3 services here. Projects that I worked with have let's say 6-7 services minimum, because if you have 3 services, then most likely you can just combine them all into one big project, so you don't need microservices at all. Even if you have 3 services, you need 3 different servers for those services, and each server costs money, and microservices are always more expensive than a monolith application, so you should always think about that. And then the 5th problem that we have, so that was our 4th problem, which is money. The 5th problem is big difficulty when you introduce new people into your team. So what do I mean by that? Whenever I worked with microservices, we had a guy who always knew everything. So it could be me, it could be some other guy, but he knew everything. He knew how our services interacted with each other. He knew what data was in database number 1, in database number 3, number 2. So he knew everything about the project. But then what happens? This guy decides to change his job, or he decides to go into other direction, so he resigns. And what happens? No one knows nothing about the project. And the same comes for new people. Whenever you work with microservices, it's really hard for you to get the grasp of it, because you have a whole new project, and that project is distributed among different projects, among different computers, repositories, and so on. So it's always easier to introduce new people into your team when it comes to simple monolith application, simple project in one repository. When you work with microservices, it's really hard to create a new team, so introduce new people and get rid of the old ones, because you should, as a person, you should know everything about every service. So let's say I work with users service. If I want to work with or interact with orders, what I need to do is know how to do that properly, and I need to know how orders service interacts with my service. So there is a lot of stuff that goes into it, and I don't want to discuss all of it. If you're interested, just write down in the comments or write me an email and we'll talk. So I will give you more examples. But it's very hard to manage your team when it comes to microservices. It's far easier to manage something like a monolith application, and that is our 5th problem. The 6th one is kind of interesting because we already mentioned it, interaction between microservices. So what is the problem here? You can watch my other video on HTTP versus event-driven architecture interaction, but the main idea in interaction is that you need to make interaction atomic. What do I mean by that? Let's say you have an order, right? Our example, we make an order in our online shop. When I make an order, first of all, what I need to do is go to users and check my balance. What happens if users are not available? So if that service is not available. In monolith application, if something is not available, your whole project just falls down, and you can fix that very quickly. But in microservices, what happens if we have, say we have something like this? Orders goes to products goes to users. What happens if both orders and products work, but users does not work? Or what happens if users works, so the data is changed here, but orders turns off mid our interaction? What happens in that? And interaction is always hard because you should always think about about dependencies. So what do I mean by that? One of the advantages of microservices is that each service can be independent. So you can update users to users 2.0, so that service, without touching products and orders. However, you can only do that if your microservices interactions are correct. Let's say that you update users, but for some reason, orders is dependent on some information that is returned from users. You use some function, so your orders used some function from user 1.0, and we remove that function in users 2.0. So what happens next? It's very easy to make your microservices dependent on each other, and if you do so, you just have a distributed system. You don't have microservices, because each service should be independent of any other service in our system, and that is interactions. That is all about interactions, and that is probably one of the hardest parts in microservice development. So you need to think about your interactions, because you have something very simple like HTTP requests, but most of the times those are dependent. So if you update one service, you need to update another one. Or you can have something like event-driven architecture, but that is really hard in terms of understanding your project. So I'm not going to say anything else because I have another video on that. So go watch it and understand everything about microservice interactions. And the last thing that we're going to talk about today, it's not the last problem because microservices have a lot more issues, but the last problem that we're going to talk about in this video is problems with deployment. So whenever you work with a simple monolith application, you only have to deploy it in one server. But if you work with something like this, so with microservices, then you have to deploy it into 3 different servers. You have to work with 3 different databases, so set up 3 different databases, and of course what you need to do is monitor them, because if your user's service is turned off, then your project is going to work partially. That is one of the advantages, by the way, of microservices, is that if your user service is turned off, you can still query products, or you can still create products, or you can still access some orders, but still you have to monitor your services to make sure that if something turns off, it is turned on as soon as possible. You need to monitor your services to understand which service should be duplicated. So let's say we add more powerful servers, or we duplicate, so add 2 servers instead of 1 for our product service because it has more load on it. There is a lot of things going into the deployment and monitoring of our microservices, and that is why DevOps profession is so popular right now, because they typically work with microservices, right? Well, you should do a lot of stuff, a lot of automation in order to successfully deploy and update microservices. What I want to say is that a lot of people think that this is an upgrade. So microservices is an upgrade to our application, but actually that is wrong. That is completely wrong, because microservices are not an upgrade. Microservices are a solution to a problem that is otherwise unsolvable. So without microservices, you couldn't have Google. There is no way you can manage all of the Google services in one repository. Microservices did not improve Google. Well, maybe they improved some stuff. They added some cool features that programmers may use, that DevOps people, admins can use, and of course they help in some sense. But the thing is, it's not an upgrade, a solution to an unsolvable problem, which is big code base, unmanageable project in monolith form, and all that stuff. So sometimes you need microservices, and if you want, I can create a new video talking about the advantages of microservices, because there are a lot of advantages as well. But always remember, it's not an upgrade, it's a solution. If you want to talk more about microservices, then you can write me an email using the link down below. But that's it. Thanks for watching. My name is Andrew, and bye bye.